All right, gentlemen, we're on 4.5, day 2 of 2, and it's the last handout before we study for our test. So let me screen share and get this show on the road. We are going to work on, not that handout, but this one right here. All right, 4.5, day 2 of 2. So a recap. BEDMAS describes the order of, remember, operations. That was the same thing on the last day's handout. And then blank is a symbol to represent a value that can change. I'm not sure why the blank is so tiny, but it's a variable. Sorry about that. An equation. It's kind of a hint by having the and there. An equation is a mathematical statement that says two expressions are equal, and numbers such as 20, 21, and 22 are called consecutive numbers, or just consecutive numbers. All right, multiple choice. Here we go. Andre sells cell phones. He's paid $15 per hour plus $5 per cell phone sold. Which expression represents his earnings? So the way I like to do these is just try and come up with my own algebraic expression and then see if there's one that matches it. So it's $15 per hour plus $5 for each cell phone sold. So like 15H plus 5C. So this one doesn't have anything next to the 15. So this answers out automatically. All right. So I'm going to cross that out. And then 15T. This one looks like it's the same. No variable in the 15. And this is way out to lunch. This one they used, instead of H for hours, it seems they used T for time. So no big deal. They used a different variable. But this is one of those hints where our reminders where we have to use let statements to let people know what our variables represent. Obviously, the assumption here is that T is time because it's $15 per hour plus $5 per cell phone. So that's our answer B. Which equation represents this sentence? 5 centimeters less than double a length. Okay, this is putting English into math, right? Is means equal. Okay, 5 centimeters less than means subtraction. Double a length. So a length, we don't know what that is. We're going to call L length, for example. Double it is 2L. Is 25 would be equal 25. 5 centimeters less means you're going to subtract 5 from something. Well, it says 5 less than double a length. So we're actually going to reverse the order. It's going to be 5 centimeters less than that is 25. You see that? 5 centimeters less than that. But the way it's worded, it comes first. 5 centimeters less than double a length is 25 centimeters. But that's the proper way of writing it with English. And so you have to be able to put that into math or into algebra here. So 2L plus 5 is incorrect because it's adding 5, not less, 5 centimeters less than something. Okay. L divided by 2, the length divided by 2. Well, are we dividing the length by 2 or are we doubling something? We're doubling. So that's definitely out. Double a length minus 20L, double a length minus 5 is 25. There we go. And the reason why this one's incorrect, the last one, is because you're doubling the length, distributive property, but you're also doubling what you're subtracting, the minus 5. So that's not right. So B is our correct answer there. Write an algebraic expression to represent each description. Okay. Triple a number. Remember, a number could just be X. So triple a number is triple X. The number always goes in front of the variable. 6 less than, if something is 6 less than something, we know it's going to be minus 6. And it's 6 less than double a number. Remember, a number is X. So 6 less than double X is 2X minus 6. Write an equation this time, because it means you're going to have an equal sign to represent each description. 5 more than, obviously, plus double a number. Okay, that's double a number. Is 47. 5 more than double a number, you have to write the double number first because it's 5 more than that. Not just doubling it, you're adding 5. It's 5 more than double, equal 47. The sum, addition, of 2 consecutive integers is 63. Well, the first number is going to be X. The second number, we learned this last day, is X plus 1 equals 63. You can also do this simplified. So 2X plus 1 equals 63. You can do that if you like. The sum of 2 consecutive numbers. And that's where it would stop. You're not going to go solving for x. It didn't ask you that. It asked you to write an equation to represent each description. Okay, so let's move on. All right. A parking meter accepts only quarters and toonies. Guys, I'm not going to lie. This is a bit of a tricky one for some people. So again, the Kyle one that we did last day was a little bit difficult. The consecutive number ones, not so bad. This one, a little challenging. Okay, so please, if you can do this and replicate this, I promise you'll be in good shape for the test. A parking meter accepts only quarters and toonies. There are 31 coins with a value of $37.50. Remember, our let statement is about to come from here. How many quarters and toonies, and how many quarters and how many toonies are there? I always hate how they spell the word toonies with T-double-O, because isn't two when you say money, like TW, it's T-W-O? Anyway, maybe just a math teacher thing. All right, so we are going to try and get our let statements down. If I can find my cursor. Found it. Maybe not. There we go. A parking meter accepts only toonies and quarters. Okay, so there's 31 coins in this meter, this parking meter. And the parking meter only takes toonies and quarters. Also weird. You think it take toonies and loonies, right? It only takes toonies and quarters. There are 31 coins in there. So the 31 coins in there, they're a mix of toonies and quarters. I don't know how many toonies, and I don't know how many quarters, right? It could be 29 toonies and 2 quarters. Well, probably not, because the total is $37.50. 29 toonies is that would bring us over the total. So it's not that, but there's a mix of toonies and quarters. How many of each? Now, this is where most people make some mistakes. They jump to conclusions because you're doing math in your head and they start thinking, oh wait, 8 quarters is a toonie. So if that's not the way of thinking about this. Okay, let's just start slowly with our let statement. Okay, pay attention because this is getting a little bit confusing. So I'm going to use Q and T. So let's say let Q represent the number of quarters in the meter. Okay, so if I told you, there's 31 coins, by the way, right? If I told you, and that's some of our important information, 31 coins and a value of $37.50. It says provide an algebraic solution. So we need to use expressions or equations to solve, like obviously an equation here. And don't forget from last time, LEST, right? Let statement, equation, solve. And I told you you can use therefore. So we're going to use T for therefore, LEST. Okay. If I told you there were 29 toonies, you say, well, if there's 31 coins total and 29 of them are toonies, then the 30, 31, there's only 2 coins left. Those got to be the quarters, 2 quarters, right? That makes sense. If I told you there were 10 toonies, then you say, oh, there's 10 toonies. There's supposed to be 31 coins altogether. 31 take away the 10 toonies leaves me with 21 quarters. Think about that, right? If there's 10 quarters, sorry, 10 toonies, if I told you there are 10 toonies, then you would just say 31 minus 10 is 21, right? Then 21 has to be quarters because altogether we have to have 31 coins. So that's what we're going to do with our let statement. And this is the part that confuses people. So pay attention here. Let, I don't know why that's showing up there. Let 31 minus Q represent the number of toonies in the meter. So again, if you know there's Q is the number. Q is the number of quarters. Could be 5, 10, 15, 2, 3, 7, 9. Who cares? It's going to be any number. It's a number. 31 take total is how many coins minus however many quarters there are. The leftover number of coins has to be toonies. Okay, so pay attention. Now that's just the number, and this is really I asked you to write these statements, right? That represent the number. That's key information. So if quarters, if Q is the number, here's where I come up with my equation. I know the value of a quarter. I might put this a little higher. A quarter is worth 0.25. A quarter of a dollar, or 25% of a dollar, plus the number of toonies. Again, 31 minus Q could be 15, 12, 10, 9, 5, 22, whatever. But each one of those is worth $2. So I'm multiplying 31 minus Q times $2 because 31 minus Q is the number of toonies in the meter. If I multiply it by 2, that tells me how much it's actually worth in dollars. So it's how many dollars do we have in quarters, or how much money do we have in quarters, and how much money do we have in toonies. Altogether, the total amount of money has to add up to $37.50. This is the hardest part, getting this equation. Solving this equation should be the joke, okay? But I need you to remember that Q is the number, okay? I'm gonna highlight it, the number, so that's the number and the number, okay? That's really important, okay? So 25 cents per quarter and $2 per toonie gets you $37.50 altogether at the end. So now how do we solve this? We have to use a bit of distributive property. So I have 0.25 Q and take the sign with you and distribute here. That's what we're doing. Okay, so 2 times, sorry, let's take that like that. And 2 times, should look like this. 2 times 31, so it's 62. And 2 times negative Q, which is negative 2Q, equal 37.50. Remember, once you distribute, those brackets are done. We're finished with them. Now, if I wanted to collect like terms, one thing I'm going to do is going to collect this right here, 0.25Q minus 2Q. Well, that ends up being negative 1.75Q because 25 cents take away $2, or 20.25 take away 2 is negative 1.75. And what I'm going to do here is I'll just put plus 62 equal 37.50. We're going to leave this as negative 1.75Q, and we're going to bring this guy over to the other side, and we get 37.50 minus 62. I end up with negative 1.75Q equal negative 24.50. If you use your calculator, you'll see that. Then we divide both sides by negative 1.75. And our wonderful answer, the number of quarters, is 14. If quarters is 14, then 31 minus Q is equal to 31 minus 14, which is 17. And we got to write our therefore statement. Therefore, there are 14 quarters and 17 toonies in the parking meter. If I can spell. Perfect. Okay. All right. That one you can pause, rewind, do what you need to do. This one is a little bit simpler, and I think it's our last question. So way to go making it to the end here, guys. So pay attention here. Charlie earns $150 more per week than his roommate Chris. Okay. Charlie earns $150 more than Chris. So if Chris is X, Charlie makes X plus 150. Stan earns double what Chris earns. Well, we just talked about double a length. If Chris is X, then Stan earns double X or 2X. Together, the three of them earn $1,050 per week. How much does each person earn per week? Okay, so let statements. When I'm trying to figure out my let statement here, let X represent, again, how much does each person, remember? How much does each person earn per week? Let X represent the amount that, who should X be? I think X should be Chris, and here's why. Because Charlie is in relation to Chris, and Stan is also in relation to Chris, okay? So because they're both in relation to Chris, it's easier to call Chris X. Let X represent the amount that Chris earns per week. And so if that's the case, then let Charlie earns 150 more than Chris. He's going to be X plus 150. Let X plus 150 represent the amount that Charlie earns per week. And then let Stan earns double, 2X represent the amount that Stan earns per week. And I like to do this sometimes to make life a little easier. I think I went too far. just to help some guys understand what's going on. Okay, so if I kind of line those up, okay, X is this guy, X plus 150 and 2X. So our equation is going to be X plus X1 plus 150 plus 2X. Altogether, they earn 1,050 in a week. How many X's do we have? We got X plus another X plus 2 of them. So altogether we have 4X equal 1,050. And I'm going to go a little quicker this time. I'm taking this positive 150 and it's switching teams. So it becomes minus 150. All right. 4X equal 1,050 minus that. So 4X equal 900. Divide both sides. You don't have to show this, but just for the sake, X equal 225. So that's what Chris earns. Charlie's earnings, he gets X plus 150. So he is 225 plus 150 equal $375 for him. Okay, and then Stan's earnings, the last guy, Stan's earnings, he's equal to 2X. So it's equal to 2 times 225, which is $450. We still have to put the therefore statement, boys. That's not what I want to do. All right, looks like I'm gonna have to, can I try it here? That's not gonna work. All right, no problem, we'll do it by hand. Therefore, Chris, Charlie, and Stan earn 225, 375, and 450 per week. And I'm going to use the big boy words here, respectively. What that means there is that, let me put the period. What that means there, respectively, means that if I say Chris, Charlie, and Stan, then that's Chris, that's Charlie, and that's Stan. So in the order that you said them, it means respectively, okay? All right, guys, that's it. Study, 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 and we'll have a review period and a test, hopefully. Talk soon. God bless.